Okay, so one final last video with the spot welder. So I have increased the current by adding an extra turn on the secondary here. So I've got 4 turns instead of 3 turns. So the output voltage now has gone up to 4 volts from 3 volts. Okay. So total power with those leads that I had with that spot, that system I had connected here, I can draw roughly about 1000 amps. But to weld that thick plate that I had, this thick plate here, is still not powerful really, I think, to do that. And because of the cross-section area. I can weld 2 nails together pretty good. Okay, that's fine. But to weld a plate that wide, you need about 5 to 8,000 amps, which I'm never going to really get with this, not unless you use a smaller and thinner plate. But because I don't think I'm going to be using this spot welder that much, probably hardly ever, I thought to get a more use out of the unit that I've built is to have an auxiliary output. And instead of a spot welder, I can use just the phase angle control. So I can vary the voltage, maybe a small motor, and I can change the speed with it. Okay, so I'm going to produce a new front panel screen. Okay, and there you can see what I've written here, switch at the back. So I'm going to have a switch at the back. I'm going to have 2 LEDs here in the front, and one's going to be for welding, for the spot welding, and auxiliary. So the switch in the back, okay, that I'm going to install right there, and it's going to be one of these, let's see, one of these switches here. Okay, it's going to switch the output to a plug at the back that I'm going to put here, an output plug similar to this, but a female one. And the controls, the software is going to change again, and the control on the cycle is going to be here. It's going to go 1 to 49 cycles, and after the 49 the readout will be in seconds. It will go from 1 to 5 seconds, and after the 5 seconds we'll display OP, and the OP stands for on pedal. So here it just explains the switch at the back switches between welder and auxiliary output. Cycles is between 1 to 49, then 1 second to 5 seconds, and then OP. And while you hold the pedal down, okay, you can vary the power. So pedal is held down while power can be varied. So while you hold the button down, the foot switch, I can change the phase, and therefore I can change the output, and therefore you'll be changing the voltage and controlling the speed of a motor. Of course, I'm risking that since then it's on the pedal here, that you could blow up the triac if what you're running out of the auxiliary, if the current is high or if you got a short circuit, you're risking of blowing up the triac. Okay, that's the only issue with that. But I thought that's what it's a better option to be more versatile than just a welder, since I think I'm hardly ever going to be using it. So I'll be doing that. Okay, so now I've got to make that. So the switch is there. So we got to fit this. I've got to cut that hole there. Same process as the switch. By the way, the idea of using the stepper drill is so you don't go all the way and damage the components inside. Since I'm not removing the whole thing apart. If you use a drill bit, there's a chance you'll go in and hit something. But with the stepper drill, we'll stop at the next step, since it's got the steps. Okay. And now to protect the winding, we'll put sheet of aluminium so I don't hit the windings. Okay, so it's all done. Now this will fit there, and it came pretty good, tight fit. Doesn't move. So that will be the auxiliary out, and that's the inside look. Right there, between the fan and the transformer, not much room. This came a bit close, but there'll be insulation on this, so it should be okay. And now all the wires connectors have to come off, because I'm going to change the front screen and put the extra 2 LEDs in the front. So you just have to unsolder the neutral here of the indicator lights. Okay, so I haven't stuck it on yet. I haven't removed the sticker backing, but I've done the holes there just to see how that's going to align, and then I shine a torch if they're aligning to where that has to be. So I see how these spots are. Okay, so this system that I'm using now, I never tried it before, so I have started peeling the sticker here. So I'm gonna just tape this up in that position there, hoping I'll be able to line that up while I place this. I think I have to peel a bit more to give me, look at that, I'm damaging it already. It's full of lines. No good, mate. Almost impossible to do it right. So I'll have to print another one. Okay, printed another one. The only difference now is the printer had a few problems and it's got ink in a few spots. This is the second one I've printed again after, so this is the third one in total. So I'm not going to reprint anymore. Some of the ink must be getting stuck somewhere underneath the cartridge there and create a few spots. Doesn't matter. So just stick in the bottom here first, and I don't know, there we go. I'm hoping it will work. It might be a success. I think going from the width instead of from the height, from this point upwards, I think it's better. So those pins, the idea of the pins, that's hopeless, it's not good. So now it's a matter of cutting with the Stanley knife, with the blade, cutting around the holes. Almost finished. Overall it came a bit better than before. These of course didn't come 100% perfect, the alignment, but better than the first one. So there's small improvement there. And these are cut with the knife blade against the aluminium. Okay, from the inside, from the back, and then from the front. That way. Same thing there. Now I've got to do this one. Then I'll go with the blade from the front as a final trim. You need a brand new blade, otherwise it will not come good. This aligned pretty good, this section, for some reason. Anyway, you get the idea. That's how it's done. I gave the panel a coat of varnish spray, and this is the finished result. I think it came pretty good. The only issues was the ink here from the printer, but otherwise nothing's 100% perfect, but it's pretty good, considering the way you have to stick this sticker on after, of course, you got the holes already drilled, okay? And if you put the sticker on and you drill everything after, you'll wreck the sticker, so it has to be done this way to get a better result. Okay, so here I prepared the extra wires to go from the switch to the auxiliary output, which is going to be this plug. And so I've cut the wires already to length. I just have to put some terminals, and these wires are going to be soldered onto the auxiliary plug. We don't have to work out which one the neutral is because it actually tells us here. It says N there for neutral. Actually, I should put some heat shrink here. Ready? So put the heat shrink. The active or the live. The Americans use hot. Normally hot are used for audio stuff, but from what I know anyway. But Europeans or English use live. Australians use active. I was brought up with the live. British system. So that's the solder there. I'm using my famous soldering iron, the one that can read negative below 0 temperatures. And that's the neutral. Maybe I can add a bit of solder more. Soldered in. Okay. Now this part, it's got an extra tag here, so I don't need that since this was for something else, this wire, so I can just snip that off there, and therefore now it's a normal spade female. And put the insulator on. Okay. We'll strip it. And this one, I'm going to put one of these on. Doesn't seem like it's long enough. Let's see. Should be. It's just not going in enough. There you go. Now I could see the cable there. Just on the edge. There is a special crimper for this, but I do have it. But I'd rather just use this. It does quite a good job. And crimp it a few places. There we go. So that's installed in there. The earth can actually run behind the transformer, and we'll go to the other main earth terminal that will solder onto the main earth there. The extra neutral here, that's just to run the indicator lights on the front. That's why I ran 2 blacks. So this will plug here. The triac is going to go in the middle of the switch. Just plug there. Actually, I plugged the wrong one. Sorry. It's this one. and this will run to the neutral, and we're gonna go on the terminal there. So that will have two on it, the same as this one. So it looks better that way. And it is still electrically correct. Of course, the correctness has to be first priority, but I'll do the other from the switch to the transformer. I haven't used this crimper for a long time. We'll see how we go at this. Pretty sure it goes that way. Actually, hang on a minute. I got two. Let's see if this one can accept a bigger cable. I think I'll save this one. Okay. Let's have a look to see if it's correct. And you can see that was no good, because I pulled it right off. I had a feeling I was on the wrong crimp. That's okay. So that means I have to be on the front one. Is that the one I said I was going to save? Okay. So, yeah, this crimper is not very good. I had to go on the smallest one, which probably is a bit too tight, and so I couldn't compress all the way. This says 22 to 18 to 22 gauge. Oh, and I forgot to put the insulation. So I think I'm going to have to cut it off again. Okay, so that's done as well. So now that one we'll plug in the bottom, and we'll go to the transformer. So the input out of the track is in the middle, and the auxiliary at the top, and the bottom is the welder there. And not that it needs it, because these are going to have insulation, but just to be more safe, we'll cut a bit of insulation, transformer insulation here, and we can glue that there. And I'm going to use some double-sided tape, I think, to stick that on. Just clean the surface. Just wait until the alcohol dries. Okay, so we got some extra protection there, and the earth is passed through the terminal of the other earth, so just gave it a bit more solder there. So that earth feeds the other auxiliary earth. So the double pole switch, one side is switching the auxiliary, the other side of the switch, it's a separate circuit that indicates in the front panel whether it's on this welder or an auxiliary welder or the auxiliary output. Okay. And here is the circuit diagram of the control circuit. So over here I have the circuit which you saw before, and for the NY-DO1 circuit board, and actually here that's not a neutral there, so let me just remove that. What's going on? Okay. So anyway, get back to this is the control circuit of the wiring inside the spot welder. So this is the extra switch that I've put, the auxiliary switch. At the moment, it's showing it's switching to auxiliary. So the output from the triac here switches the auxiliary output through the back plug, and the neutral is connected to the main neutrals. There's my main switch. The power in goes into the main switch. Again, I'm using 2 fuses here. The neutral hooks up straight to the microwave oven transformer. Okay. And the active goes to the 12 amp fuse. Then it goes to this 10 amp circuit breaker. The LED in the front panel, the red one, is hooked up after the circuit breaker. So if this circuit breaker opens, that LED will not light. Basically, it's an indication whether the fuse has gone or the circuit breaker has gone. And then I've got another 100 milliamp fuse to run the transformer, to run the circuit board, to run all the circuit here. So that's it there. That connection there is this connection on that little transformer, and it goes to the main neutral. Yeah, and the auxiliary switch there, you can see it's a double pole, so that's one pole. The second pole is switching the indicator LEDs in the front panel, the green and the amber. So for the welder or the auxiliary, just so you know which position the switch is in. I think that's pretty much it with that. Just installing the extra indicator lights. So this is the neutral for the indicator light, and as you can see, I just use just a terminal on this instead of soldering that one. One thing I haven't done, I haven't marked which ones they are. I'll have to work that out later when I put them on. Which one is the green and which one is the amber. And I'll have to create another power, and I'll get that from the control fuse, the 100 milliamp circuit. So that will connect onto this one here. I'll have to cut the insulation from there. And I found another connector that I had from this machine that was scrapped. I'm not going to bend them, it will make it too hard to take it off again. But we'll just solder it, and the solder should just fill that in there. Now hopefully this heat shrink will fit there, because I think I should have used a bigger one. Oh, that's alright, it fitted. Can stay like that. So now this can fit in the middle. Okay. All right, so all the wires are connected to the switch there, and that is what I've routed the wires. Okay, so I hooked everything up. The power supply to this, we're just going to give it a test again and just turn up the voltage slowly. Okay, coming on. Current's okay here, nothing seems to be wrong. And we're up to 40 volts. Okay. So we'll go to the settings here. So now this goes to from 1 So I got more separation now because I only go to 1 to 49 cycles, and after the 49 we got 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and OP on pedal. So now when I press the pedal, it stays on. And there's the current there, the percentage. Okay, we'll try. So it's on auxiliary. Try the switch at the back. Now it's on the welder. So leave it on auxiliary. Now I do have a load connected to the auxiliary, and I'll show you here. I've connected a globe, and I have a motor which is not really connected yet, and so that's the auxiliary output and the input. And what I have discovered, if I disconnect the plug at the back, the auxiliary, you see the Welder LED comes on. And once I connect the plug at the back, okay, I'll connect that, and when it's plugged in, you see it goes out. And that is because the circuit on that's the output of the triac. And remember, there's the snubber there, and the snubber is actually passing enough current to light up the LED, of course, through the capacitor and the 49 or 47 ohm resistor. I'll have to look at the circuit. So that's the reason why there, so that's not a problem. And regarding the LED, the Welder LED was coming on when you switch it to auxiliary, if you have no load on the auxiliaries, because of this circuit here, the 39 ohm, actually it's 39 ohms here, in series with this 10 nanofarad capacitor from the active, okay, that's enough current there to light up that LED. Okay, but once you have a load, then that voltage there will be taken away by the load to neutral, and that will not light up. So same thing when it's on the welder, when that switches to that point, then it goes through the transformer to neutral, and it takes away the voltage produced by this capacitor and this resistor here from the active, from the live to the load. So I'll give you a small test. I've got the foot switch here, and because it's on pedal. Now, while it's on pedal, it stays on until I release the foot switch. Okay, I can adjust the power output, okay, while I hold the pedal down. Okay, so you can actually hook up another welder transformer to the auxiliary, and I use this purely just to switch it on, off and on, with the timing that I have built in this. Or if you want to test a circuit, that's a resistive load at the moment, okay, the globe. And now I'll hook up the motor, induction motor here, just a small one, okay, and when I press the pedal, the motor runs, okay, and there it is drawing the power. Now I can increase the power here and the motor speeds up. So now I'm controlling the speed of the motor. Now the other thing that I want to show you is, and most electronic people, they would know about this, just hooked up a small oscilloscope here on the auxiliary output. Okay, so that's the actual wire that's coming from the auxiliary at the back there. And hang on a minute, let's change the time base on this. There we go. So now I'm changing the power, right? Change the time base again. And you can see the distortion of the AC wave because of the back EMF of the induction motor, right? Now if I disconnect the motor from the plug here, then I get a perfect, I regulate, turning up the pot here. Okay, you can see the phase angle shift changing there. That's 99%. Okay, but as soon, I'll have it on low and I'm going to plug the motor while it's still got some power there. As soon as you hook up the motor, you can see how the back EMF is reversing the wave, creating an opposing voltage, okay, to the current flow there. Now you see, if you recall the output of the triac from the circuit, okay, it's not just a pulse, it's not just a pulse to the triac, it actually keeps it on. If you don't do that, that back EMF, okay, can make the triac not fire or switch off. So I think it's called brute force, where you leave the triac switched on until just before it hits the zero crossing. Okay, you switch it off just before zero crossing. So therefore that wave, that back EMF, okay, cannot create a window of where the gate voltage is, okay, where it sending it to a negative, and the triac will not turn on. So that's the only reason why I'm showing you the wave there. You can see the back EMF, okay, and that's done by the motor. So this, from low speed, which is about the lowest, don't worry about this voltage here, it's actually wrong. It's about 60 volts RMS on the 1%, okay. I can vary the motor all the way with no problems. It's not switching off or cutting out, okay. Okay, so that's the working of it. So that's it there. So the extra reason, how I said, the auxiliary, is to do some testing, maybe like this, or for example, you know, if we change this to the That's 15 cycles there. Okay, well, let's give it 40 cycles. Okay, press the pedal, the foot switch, and the LED will stay on for 40 cycles. We'll change the power. Okay, give it more power, and you can see the double pulse there flickering. Okay, or if you want to have it on for 5 seconds, there you go, 5 seconds on. So anyway, I thought I made it a bit more versatile to get more use out of it, maybe. So that's it.